Greetings everyone, my name is Amir Farid bin Shahrin, and today I would like to be presenting my final year project title, which is Fatigue Crack Group Behavior of Two Interacting Cracks Under Tension. Okay everyone, before we begin I'd like to ask, does anybody here know what fatigue is? And no, I don't mean the fatigue that you would feel when you're tired. Now, the fatigue that I'm asking about is material fatigue. So what is material fatigue or fatigue failure? So fatigue failure is a phenomenon or an occurrence by which a mechanical structure breaks down due to repeated cyclic loading. In layman's terms, a mechanical structure would break down or would break apart because of wear and tear, because of excessive use over a long period of time. So this is very important for us engineers to understand what is fatigue. And because of this, a lot of studies and findings were done on fatigue in order to understand that why this phenomenon happens, and is this phenomenon present in any other material? And the short answer is yes, it is present in every other material, and the phenomenon occurs which is due to the fact that when fatigue starts, the material itself or the mechanical structure, at the surface of the mechanical structure, there will exist or to exist a small crack that over a long period of time will start to propagate and become bigger and bigger to the point where fatigue failure occurs. So the problem with fatigue is that very shallow understanding of it will lead to a lot of poor design choices that will cause a lot of mechanical failures to happen in the future. And these mechanical failures can be dangerous given the circumstances. Now, an engineer who designs with fatigue in mind will not necessarily design something that will cause fatigue to not happen, but they will design something that will make it so that fatigue happens a bit later than one would expect. So, because of that, things like this would occur much later than we thought they would occur. These items here that you see in the slide itself are examples of items that have gone through fatigue. Why do I show a lot of it? Is because 90% of all mechanical failures are due to fatigue. Now, for my investigation, we go into crack interactions between two cracks. So in the picture here are examples of cracks and the interaction with each other. It's not a video, it's just a picture of it, but these are the two cracks. These are the things that I will be investigating in my investigation or in my final year project. So the effects of these interactions may cause the crack to grow even faster, or it may even slow down the crack growth process. So the objective of my research is to investigate the interaction effect between two cracks. Aside from that, I need to analyze the influence of the crack size on the crack interaction. And lastly, I want to evaluate the crack interaction between the two cracks in a variety of positions. So my research methodology is that I will use the rotating bending test machine in order to simulate the wear and tear of a specimen. The surface of the specimen, which I will need to examine, will be examined using the replica technique. And the replica technique uses a plastic film that is dipped in acetone, which will then be put onto the surface. This will cause it to take shape of the surface itself, and I can use this to my advantage because UTM, or University of Technology Malaysia, has a computerized microscope that I can take advantage of to examine the surface itself, to measure the surface, and I can tabulate that inside a table or a data sheet, and afterwards we can discuss about the findings itself and see whether or not the objectives are met. Since I don't have all of the data to make a conclusion, my expected results is that the crack interaction will have both an increasing and a decreasing effect on the growth rate. Aside from that, I think the bigger the main crack, the faster the interaction will occur. And lastly, when an angle is introduced, I think the crack interaction will decrease, which means that the growth rate will also decrease. So that's all from me. My name is Amir Farid. and this has been my presentation for final year project. Thank you.